let's take a look at binary search. For binary search, one of the conditions is that we have an ordered array, right? So we have an ordered list, right? So this is an ordered list, and we can see that this is an ordered list. The first element is 8, then 12, then 13, then 17, then 25. So we have an ascending order here, right? So this is an ordered list. Okay, let's give this array a name. For example, let's give this array the name of let's call it marks, right? And let me also number these elements. This is element number 1, 2, 3, 4 and 5. Okay, now as the name suggests, we are basically going to be searching for a value through this array. Okay, for example, we are searching for a value, let's say we are searching for 17, right? Now the key concept here is that this is a binary search. Remember, binary is like in binary we have two options, 0 and 1, and that is the whole concept here, right? We are going to break this array up into two parts, right? We're going to break this array into two parts and then do our searching. Okay, so I'll just explain the algorithm to you now. Let's say we have two pointers, right? And one of the pointers, is going to be at the first element of the array, and let's call this first, and this pointer is going to be at the last element of the array, and let's call this last. Before we move on, I just want to make one minor edit here. I don't want to call this array marks because the code I have for this has the name of the array as list. Okay, so this is the name of the array. List is the name of the array. This is the identifier of the array. Okay, so let's start solving our code. So what we have here is a pointer that is pointing to the first element and a pointer that is pointing to the last element of the array, which means what? The value of first is 1 right now and the value of last is 5 right now. Okay, the way to do the search is, and remember this is the value that we are searching for. The way to do the search is that we find the middle of this array. So what we are going to do is, to find the middle of the array, we are going to add first with last and divide by 2. Now this will give us what? 1 plus 5 divided by 2 is basically what? This is equal to 3, right? So this will give us the middle value. So we have another pointer called middle, and middle is now going to point to 3. Now we are first going to check whether the value lying here, right, in this middle element, if this value equals 17, right? So we're going to check whether this value 13, whether it is equal to 17 or not. If it is not equal to 17, then we can what we can see here is that 17 is larger than 13. 17 is larger than 13, which means what? Which means that the number that we are searching for must be in the upper half of the array. Must be in the upper half of the array. We don't need to look behind this point, right? We don't need to look behind middle, rather we should be looking in the latter half, right? In this part of the array, right? For our value 17, because 17 is greater than 13. Okay, so what we are going to do now is we are going to set our value of first beyond this point, right? Beyond this point, more than the middle, right? So we need to move this first. We need to move first this boundary. From here we need to move it somewhere here, right? Because we've already checked middle, so we've already checked this value. Since this is not equal to 17, we need to check in this portion of the array. Okay, so what we are going to do is we are going to set the value of first equals to middle plus 1, whatever middle was, and middle was what? Middle was 3, right? So the value of first now becomes what? 4, and the value of last is still the same, 5, right? So in a way what we are going to be searching in is this array, right, starting from here and ending here, right, and the middle for this part can be calculated using first plus last divided by 2, and first in this case is what, 4, and last is what, 5, right, and this is going to come out to be what, this is going to be what, 5 plus 4 divided by 2, which is going to be 4.5, but we'll ignore the we'll ignore the decimal part, right, so we'll just consider the answer to be 4, right, so we'll ignore the decimal part. And in this case middle comes out to be what, middle comes out to be 4 also, right, so middle is also 4. And once again, now that we have established the middle of our of the remaining part of the array that we have, right, we've established the middle, we are going to check whether list middle, which in this case is what, which in this case is list 4, right, and list 4 is 17, whether list middle equals 17 or not. Remember, this was the value that we were searching for, and this is equal to true, this is equal to true, right. So this means in this case it took us 2 shots, right. The first shot was checking this part of the array, this was the first middle that we checked, and this was not equal to 17. In our second shot we were able to find this value 17 in the array, right. So what this gives you is an idea of how easy it is to search for values and how quicker it is to search for values when we are using binary search. Okay, let's start again. Let's say this time we are searching for a value, for example 28, right. Let's say we are searching for a value 28. Okay, so how is this going to happen? Once again we are going to, at the start we are going to set the value of first, so this is going to be first, right, so this is going to be equal to what, 1, and last is going to be equal to what, last is going to be the last element of the array, and this is going to be 5, right, 1 2 3 4 and 5. The first element that we are going to look for is going to be in the middle, right, so middle is going to be calculated, right, and middle is going to be equal to what, middle is going to be equal to first plus last divided by 2, which is going to give us what, 1 plus 5 divided by 2, which is equal to 6, right. So middle this should be equal to 3, right, this should be equal to 3, so middle becomes equals to 3, and we search, and now we check whether 28 is equal to, so we check, you know, if list middle is equal to 28 or not, right, that's what we are checking, and the answer of course is no. And we can also see that 28 is greater than 13, which means that, you know, if we should look for 28 in the upper half of the array, right, we should look for 28 in the upper half of the array, which means that now that we have checked this element out, right, now that we've checked this element out, we need to move our first to a new location, right, we need to move our first right here, right, beyond this point, right, and once again we are going to calculate the middle, right. First now becomes equals to 4, because first can be calculated as what, first equals middle plus 1, right. We had already checked middle and we could not find our item in list middle, right, we could not find our item here, middle was equal to 3, so now we have come out with the value of first, which is equal to what, 4. So we have set our boundary to 4 now, and the other boundary is 5, and now we are going to once again calculate the middle, right, and this time when we do that, this is going to be 4 plus 5 divided by 2, which is going to be 4.5. let's ignore the decimal part, so our middle is going to be 4. So now we are going to check for 4, right, so now we are checking So middle becomes equal to what? So middle equals 4 right now, and this is gone, right? This was the previous middle, and now we have recalculated middle, and it's equal to 4 right now. Okay, when we do this check, list of middle, which is going to be what? List of 4, because middle is equal to 4 right now, is that equal to 28? And we see that is not equal to 28, because list of middle is 17, right? So what we need to do is we need to move our first to, what we know is that we should look in the upper half of the array, right, remaining upper half of the array, to find our value 28. So what we are going to do is we are going to move our first, and we are going to shift it beyond this point, beyond middle, right? So we've already checked this point, so we need to move first to the next point, right? So first is going to be calculated by adding 1 to middle, which is going to be what? 4 plus 1, and first is going to be equal to 5. Okay, now first equals 5 and last equals 5 also. So middle is going to be calculated using 5 plus 5, which is basically what? First plus last, right? Divided by 2, and this is going to give us 5. So the middle is also going to be what? Middle is also going to be 5 in this case. Once again we are going to check if list middle, which means what? List 5, is that equal to 28, right? And the answer is no. If the answer is no, we are now going to do what? We are going to follow the same routine. We are going to add 1 to first. We're going to recalculate the value of first, right? And how do we calculate the value of first? We are going to calculate the value of first by adding 1 to middle, right? Which means what? Which means that the value of first comes out to be 6. Okay, and the situation right now is that the value of first has become greater than the last, because the value of first, now that we've calculated, is equal to 6, and the value of last is 5. So we continued with the previous routine. We found our middle here, and our first was here, right? So we moved our first next to the middle, right? We moved our first next to the middle, right? We added 1 to middle, and we were able to calculate our new first. Then we used this first and this last to calculate the middle, and the middle came out to be this place, right? When we found out that 28 was not equal to 17, we needed to move this first, right? And what we did was we added 1 to the value of middle and moved our first here to this point, right? To this point. Then once again we calculated our new middle, and the new middle was what? The new middle was 5, right? And then we checked whether 28 was equal to 25, but it was not equal to 25. So what did we do? We followed the same routine. We added 1 to the existing value of middle to readjust our first, but this time first came out to be pointing at this location, which was not there in the array, but this value comes out to be 6. Now we have a situation where the value of first is greater than last, which basically means what? When this happens, when this condition happens, this means that the item has not been found, or you can say, we can call this as search failed. If we have a boolean called search failed, we can set it to true. If this is the case, search failed equals true. Okay, now we can do the same if we were looking for a value that was, for example, so this is our first, right, and this is our last, right? And what if we were looking for a value like 4, right? What would happen in this case? In this case, first this is going to be our middle, and we are going to check whether 4 can be found in this element, right? If it is not found, we are going to move this last to this point, right? Last is going to be calculated as middle minus 1. we know that we have to move last because 4 is a value that will not be found in the upper half of the array. Rather, to find 4 we'll have to look in the lower half of the array, right? That is why we don't need to move this value, we don't need to move this pointer, rather we need to move this pointer. So how are we going to calculate the value of last? Last is going to be middle minus 1. So we are going to reposition our last here. We are going to calculate the new middle and try and look for 4 in the new middle. If 4 is less than 12, then we are once again going to move our last to this point, right? And we keep on doing this until what is going to happen? Until this is going to become the middle, and we are going to check if 4 can be found here. If 4 is not found here, we are going to we are going to move this last once again. We are going to calculate last as m minus 1, and remember in this case m is equal to what? M is equal to 1, right? This is the first element, 1 2 3 4 and 5, right? In this case m is equal to 1, right? And now L is going to become equal to what? 1 minus 1, which is going to be 0. So L is finally going to move out of the array and become 0, right? And in this case, once again, first is going to be greater than last, because the value of first is 1 and the value of last now at the end is going to be 0, right? Which means what? Which means that search failed, right? Which means what? Search failed, right? So we can set our Boolean value of search failed equals true. Okay, what we are going to take a look now is what we are going to do now is quickly take a look at the code for binary search. Okay, so first what we are going to do is we are going to set the value of first equals to 1. We are going to set the value of last equals to the final element in the array. Let's call it max items, where max items equals the final element in the array, right? So in this case where we had 5 elements, right, and this is the 5th element, max items would be equal to 5, right? So last equals max items. Okay, now let's just use a few Boolean variables, right? Let's say found. If the search has been found, if the search item has been found, we are going to use a Boolean for that. Let's initially set this to false. Let's also use another Boolean variable, which is search failed. So this basically means we were searching for a value through the array. We searched the entire array and the item was not found. Initially we are going to set this to false, right? When we initially, because we have not searched the array as yet, search failed equals false. Okay, what we need to do now is we need to search through our array. Okay, so we are going to set up a loop because we want to move through the array, and this loop is going to run as long as the item has not been found. As long as the search item has not been found, we are going to keep running this loop, right? And at the same time, as long as our search has not failed, right? As long as our search failed, right? So as long as search failed, as long as our search has not failed, and as long as the item has not been found, we are going to keep running this loop. Okay, let's move forward. Once inside the loop, what is the first thing that we need to do? We need to calculate the middle. So middle is going to be equal to what? Middle is going to be equal to first plus last divided by 2. Now that we have our middle, we are going to check if search item, the value that we are searching for, if search item equals list middle. If this is true, then we are going to do what? We are going to set our Boolean variable found equals to true. However, if this condition is not true, if we have not found our middle item as yet, then we go into the else clause. Okay, else we are going to do what? else what we are going to do is basically there are three things that we need to check for now, right? One, we need to check whether first has become greater than last or not, right? This is the case in which we've looked through the entire array and we've not been able to find the item. The second case is where we want to if this is not the case, then we need to check whether we want to search the forward half of the array or the lower half of the array, right? So the upper half of the array or the lower half of the array. This would be what? This would be the case when our search item is greater than list middle, right? This would be the case when our search item is greater than list middle, and we have to look through the lower half of the array when our search item is less than list middle, right? So these are the three conditions that we need to make sure that we include here, right? Okay, so this first condition is doing what? It is telling us that if first becomes greater than equal to last, right, that means we have searched through the entire array and our search has failed. That is why we have set search failed equals to true. Now if this is not the case, then we go into the else clause, right? In this else we have these two options. Do we want to search in the forward half of the array or the lower half of the array? Okay, now what this is doing is, this is checking that if search item is greater than list middle, that means we have to look in the forward half of the array, right? In the forward half of the array. So we are moving our value, our pointer first to middle plus 1, right? And next, once we've checked that if we don't have to search through the forward half of the array, that means we have to search through the lower half of the array, right? We have to search this way, right? Which means what? We will have to move our last. So this pointer last is being set equal to middle minus 1. So we have completed this, and there is going to be an end if corresponding to this, right? And finally we had this if also, right? So there is going to be another end if which is going to correspond to that, right? And this is where this loop is also going to end, right? So we are going to just write end while here. Okay, so quickly going through our code, we first calculate middle, then we check if we have found our search item. If we have not found our search item, right, if we have not found our search item here, right, then what do? Then we check if we have searched the entire array or not. If we have not searched the entire array, then we check whether we need to move the pointer called first or do we need to move the pointer called last, right? Once we are done with that, we come to end while, and from here the control is transferred back upwards. When we go back up, we first check whether the value has been found or not. If it has not been found, and if search has not failed, if the search has not failed and the value has not been found, then we recalculate middle. Then we recheck whether search item equals to the new list middle, and that same process of checking whether we have searched the entire array. Do we need to move forward to search the next item? Do we need to move backward to search the next item? Hopefully you've understood how binary search works. And finally once you exit this loop, you can write a small snippet, small piece of code which is doing what? Which is saying that if found is equal to true, then output the value of middle, right? This was the element where that value was found. If found was not equal to true, then output value not found, right?